Well, I want to say hello to everybody and welcome to YouTube Mall Builders Tuesday night topic driven hangout. Tonight will be the discussion of JMRI basics, and we're pretty well to an end of that. So if you're getting tired of it, this is pretty much it. We'll be moving on from there. My name's Johnny Rev from Southeast Rails. Dude was supposed to be the moderator tonight, but because of unforeseen events. He couldn't make it, so he called me and asked me if I could step in for him. And I want to say thanks to everybody and for coming in tonight. The Q&A is open, so if you have any questions, please type them in the Q&A, and we'll be glad to try and answer those questions to the best of our ability. If not, we'll try and point you in the right direction to get that. And tonight's guest is Tommie. He's been here before, and we also got Andy, which likes to use a Sprog and do things a little different, which gives us a different perspective, which is always good. So why don't we start out with you tonight, Tommie, do a little recap on what was talked about last time.
All right, hey everybody, it's Tommie. You can see me on YouTube at Tommie, Tommie, 022481. You can check that. I have all kinds of DCC videos and how-tos, project updates, revisit some layouts, all that good stuff. So, on my YouTube channel, I get questions pretty regularly, and they're some of them are more advanced questions, some of them are real basic questions on JMRI. So, the last few episodes, like Johnny was saying, we've kept it pretty simple. Last week I thought was pretty good because we kind of dove into some of the meat and potatoes a little bit. I think this week we're going to dive a little bit more into that. So, without further ado, we're going to get started. I'm going to flip my screen around here, and you guys can see what I got working here. It's pretty much the same setup I had last week. And to review what I have here is basically just a piece of 1x with a couple of tracks just taped to it. I got a couple locomotives here on standby. I have my Digitrax PR3 hooked up to the bottom track, and then to the top track we have the Digitrax DB150 command station. I'm using a wireless throttle. But not to talk too much about the hardware, but they're both Digitrax products. One thing to note, there's different programmers that are out there. You don't have to use Digitrax. Andy's going to talk about, Sprog. MRC's got some programming out there, and there's a number of other companies that I don't need to get into at the moment. But and you can run these independently. So I have a Digitrax programmer and a Digitrax command station that gives me an extra layer of compatibility and cross functionality, but it is not a requirement. So I could have a Digitrax command station. I don't even need to have this Digitrax command station. I could have a different one, and I could have a different programmer, or the vice versa. I could have the Digitrax programmer, and I could have an MRC, Prodigy or some other command station that's out there to run the layout. So you're not required to get the same manufacturer. Depending on what you're looking to do, it may or may not be a thing to do. So just something to keep in mind. Topic of today is JMRI, and I have the JMRI already open up, and we've talked about that over the last couple weeks and how to get into that. But basically, if you don't know how to get in your JMRI or how to get it, just Google or Yahoo it and type in JMRI, and it'll come up with a place to get that. So what I have is, like I said, my track. I have a locomotive. This is the new Author and Ready to Roll series with the Tsunami Economies, which is similar to the Tsunami, or Soundtrax Economy, excuse me, I said that wrong, which is similar to the Tsunami. I have my throttle, and this is basically right out of the box. I did some programming to it last week. I undid all that, and we're basically going to do some basic programming using the JMRI software and the Digitrax PR3 and kind of get this locomotive up to speed. So what I have here is, I'm just going to go to speed step 1, and you can see, wow, that's, go forward here. At speed step 1, the engine's flying. It's nowhere near prototypical. If I were to put another locomotive on the track here with it, and this happens to be 3616 also here in my throttle, and I put that on speed step 1. I may need to turn that on. Excuse me for 1 second. Speed step 3, nice crawl. Switch direction. As compared to what I had on the other locomotive. You know, it's flying across the way. So what I'm going to do is I'm going to fix a couple things with how the engine is performing. We're going to review change in address like we did last week, and I'm also going to do a little bit of review with the sound if I take the mute off. If you guys can hear that, the prime mover is a little bit quiet. The bell is really, really loud. And the horn's kind of mediocre. So we're going to kind of go through and work on some of that as well. So to get started with JMRI, I'm going to take this, I'm going to move it to the other track, which is a program track, like I showed a moment ago. It's hooked up to the PR3. Make sure all of the wheels are making contact there. All right. I'm going to put my throttle down here, and I'm going to move over to the screen. Now I'm using an Apple iPad here, so I can kind of show, you know, the setup here as well as the screen. So I know it's not the best resolution, but I think you guys can kind of get the idea of what I'm doing. Let me get my viewing block set up here. Okay.
Knee go up just a tad.
Go up just a tad. I can do that. All right.
All right, that's looking pretty good.
So I have created an entry. This is the same entry I created last week. And the first tab on the ribbon here is roster entry. This could be, you know, whatever really you want. It's all user input functions are there. So right now, I just have the ID as Tommie, road number 1, 2, 3, 4, 5. You know, if I really wanted to redo this, let me find my mouse here. Whatever naming structure you want to do, just like with any program, you want to be consistent. So, you know, the road number is 7316. I usually pick an A. If I want to have a B or something, I can do that. Oh, I already have an A, so I'm going to do probably a B. I'm going to do a C. Pardon me. The road name, well, this is a BNSF locomotive, so it's going to be BNSF, and like I said,
BNSF.
BNSF 7316. Dyslexic I am, right? BNSF 7316. Anyway, all, you know, user entered, you know, type of information you want to have for this particular locomotive, or, you know, template if you want to do a template. Next tab over in the ribbon is basic. This is a good spot to get, well, what it says, basic decoder functions. And the best thing about this is decoder address. Now, as you saw a moment ago, when I was operating the locomotive on the other track, the address was 3. Most, if not all, decoders that come new out of the box or out of the package have a default address of 3. You can change that address to whatever you like. Most people change it to an address that, looks like it came up by default because I was already in here, but 7316 was the, again, the road number of the engine. You know, some people shortcut that and make it a 16 or a 73. You can do that as well. The easiest and best way is to use a full number. Most manufacturers don't duplicate numbers. If you have more than one locomotive with the same, let's say I bought 2 of these locomotives and they have to be the same road number, well then you need to get creative as to what you want to do with it. Either you renumber the engine or redecal it, or you do 7316 and 7317, whatever that is. I can't tell you what that's going to be. If you notice when I changed some of the functionality here, or changed some of the parameters here in the program, it changed color to let me know that I've made a change to the program. And if I go to hit rate changes, you're also going to notice that flash red for a moment, and then it's all clear that the changes have been made. If I go through and I'm going to change this to just pick a different number, click off it, hit that again, it just changed the address to whatever I put here. So pretty simple. Address change. Be consistent in how you number it. Be consistent in your roster entry. You'll have a lot better time keeping track of all your data. And that's basically changing a decoder address. And again, we kind of went into that in more detail in the previous video. The next tab I want to talk about in the ribbon is motor function. Now this particular one, again, is pretty simple, and it's acceleration rate and braking rate. Most people refer to that as momentum. And if you recall, when I had the engine, it really took off like a bat out of hell. There wasn't, it was real, jerky. It was all or nothing. So you can program a momentum or an acceleration rate or deceleration rate to your locomotive. Different manufacturers read these values differently. So I'm going to make this locomotive a little bit high. I'm going to do this one 75 and 75. The value range of this decoder is, I think, between 0 and 254. You see they've both changed color to a darker orange from the yellow. I'm going to write those changes on there. You see they flash red, noting that there was a change made and they've cleared. So the locomotive is going to now take, I'm going to move it to the other track here again, a lot better response to the throttle. Get my throttle back here. We'll get the center back on the engine. And one moment. These wireless throttles are great, but they like to time out after a while.
And you'll want to be sensitive with setting momentum values. They can get kind of unwieldy or unusable. While it may be somewhat realistic to have crazy momentum values, and I like momentum real well, a lot of people even turn it off or turn it down really low. I would recommend trying a little bit more momentum if you're into realistic operations. It is much more prototypical. Locomotives of many tens or hundreds of tons trains take some time to get up to speed, but what I would recommend is your switching locomotives or yard locomotives, that you set that momentum quite a bit lower, and that your road locomotives for your road fleet and your main lines, you can turn that momentum up quite a bit more. Be sensitive. Like yard locomotives, you'll pile into a whole line and run them, full out of the yard the other side if you're not sensitive with your stopping momentum. And I would start by setting a small value and adding a little bit to play with those.
Yeah, that's very good. So you see that the engine is still, flying like a bat out of hell, but at least it's not being real jerky. Now I have to go through and kind of show the next part here of setting the voltage to the locomotive. Mute this thing so you don't have to hear it run. Now, as I was starting to say, the different locoders will receive these values differently. So this one, you saw that it brought it all up to 75. It had a very small impact to the operational local. If I take a Digitrax decoder and I set it that high, it may take 15 seconds for it to get up to speed. So like Andy was saying, start off small, see how it goes, and then kind of go from there. There's two different speed control sections here on the ribbon. A basic speed control, in the case of this decoder, it just gives you a start voltage, and the next one gives you a much more range of influence of how your decoder is going to respond. So this is kind of a default speed table. It's called a straight line speed table, and it starts off when the throttle's at 0. It's not going anywhere. As you notch your throttle up, it goes in a straight line curve all the way up to whatever the max speed of the locomotive and decoder combo is. So just for the sake of keeping it simple, this first pass, I'm just going to write. Actually, I'm just going to, let's see. I can read it. I'm going to write the full sheet. As you can see there, it's going one at a time. Now, really, each one of these bars does represent a different CV that's available in your decoder. And this gives you one place for you to view all the CVs in a very, what's the word I'm looking for? Cosmetically appealing and easy to handle area. And one more thing I forgot to click here is I want to use this speed table as opposed to the option of hitting that speed table. So let me write that real quick. Okay, so I'm going to move the locomotive back onto the run track here. And let's give it a little bit of juice. A little bit better, but still kind of jerky. Run it reverse here a little bit. So one more thing I need to do is I need to set that start voltage to a much lower value, because that's still probably hanging me up here quite a bit. There doesn't seem to be any difference in what I'm changing here otherwise. I'm just going to kind of set that to something real low, like 2. Write that change on there. And let's put that on here. And hopefully I get the result that I'm looking for. I do. Okay, let's put that back on here. And put it in the forward spot. And I'm going to give it, and notice that I'm not on 3 anymore. I'm on 7316. That's because I changed the address. Look at that. What a big difference. And see how I brought it down to 0, and it took a moment for it to get down to speed. That's the momentum we programmed a little bit.
All right, now that doesn't have any effect on the speed table, though, right?
The momentum, no. The momentum basically is how long it's going to take to get up to that speed table CV value, or CV.
All right, but the start voltage, you changed that. But the straight line that you had programmed in there, does that change to reflect that change you made in start voltage? Or does that speed table just work with that voltage? Andy, we lost you. Yeah. Try it again.
You guys hear me okay?
Yeah, yeah.
Okay. So I have a table here, and I had a start voltage here. So the start voltage is basically going to kind of pick a value where that speed table is going to begin at. So its start voltage is kind of like right where this first, it's like a graphic equalizer, almost like, on your stereo. It's going to basically put where your start point is for this table to begin.
Mm-hmm. Okay.
All right, so going through, and there's a couple of options you can do here in moving this, and you can shift this, left and shift this right by these 2 buttons here. So if I shift it, you can see how it changed everything. I shift the entire thing to the left. I can do the same thing. I could shift it to the right, kind of bring it back where it was. I can go back, and I think I can do some There we go. So this set a different type of curve on there. And this type of curve is going to have the locomotive kind of start off at a gradual pace and then work its way up. About 3/4 of the way through, it's going to start working its way up to its higher part of the speed table. This is something you would see more with freight locomotives, where it takes them a little while to get up to speed.
I know.
If you wanted to,
Let me ask you something while you got this screen up here, Tommy, if you don't mind.
sure.
All right, you got that speed table there written on the decoder, okay? Now you're out there on the layout. If you take your speed control knob and it's on 0 and all of a sudden you just crank it up to where it goes almost full throttle, what's the engine going to do?
Well, in the straight line I had a moment ago, it's just going to be a constant increase and a constant decrease.
Mm-hmm.
When you start doing different curves like that, you can change how that responds. So
think of it as like a speed-sensitive gas pedal in a sports car as well. So with this curve that he has here, the early part of that knob will be much more sensitive and make much smaller adjustments in speed. But once he gets up to about half throttle, when he twists that thing at 1/8 of an inch, for example, as opposed to just making a difference in a few miles an hour as it did on the lower part of the table, it may make a difference in 20 or 25 scale miles per hour because the adjustment is much faster.
Okay.
that's a good way of putting it. Conversely, if I wanted to do something like the F40, PHs that are in service in a lot of metropolitan areas, like I'm just outside Chicago, so we have Chicago Metro engines. It's going to climb up to speed a lot quicker and then taper off something kind of like this. So this is another way of kind of getting, a prototypical response from your, decoder, depending on what type of locomotive you're running and what the application is. Now, I've only got, I don't know, this thing's, 2.5 feet long, so what I have here is not going to make an effective demonstration. I can talk to you guys about it. If I program this to the locomotive, and maybe I do that real quick, you guys aren't really going to be able to see the difference quite as well as having it on a layout and having, 4 or 5, 6 feet or more to, really see the difference. But we'll go ahead and we'll program that in. And then we get into, and there'll be a whole other section in this, then we get into using tables like this to do speed matching.
Tommy, if you don't mind, I want to just jump in real fast. For the viewers, we're starting to get a number of them. If you got questions, just type them on in, and I'll get them over to Tommy and Andy and see if we can't get them answered. All right, Tommy.
All right, so I did the programming, and I've got the throttle, and I've got some momentum on there, and it gets up to speed pretty quick. And I'm going to hit my tape there. I have to stop it. But it got to speed there pretty quick. I'll do a reverse, and so you guys can see it again. And whoop, there goes my tape. All right, so just to give you guys an idea.
Yeah, Tommy, your microphone is like it's sitting on your shoulder.
All right, let me fix that. All right, that better?
Yeah.
Okay, so the locomotive, it got up to speed pretty quick. It got up to speed so fast that, I ran off my little track here. So, I'm gonna kind of do the opposite here. I'm going to set this, you know, pretty low. And you can do this manually. You know, you can, you know, there's some preloads that are in here. And you can customize this to, you know, fit whatever your locomotive is.
So when you're doing something like this on, well, you can't change the program track to the way you can if you have the toggle switch with a neutral off. But you'd still have to take it off the program, put it on a regular track to actually be able to run it, say the 5-6 feet you're talking about, to see the effect of it.
Well, you could program, you could make changes out on the main. So
yeah, but that's dangerous.
Well, the reality is, and I said this in last week's show as well, that to begin with, for the early part of dealing with decoders, setting basic criteria like setting the decoder identification and setting basic changes that you want to make, like sound files and those kind of things. Learn on a programming track. It's safer to deal with that. Even a separate piece of flex track laid on your workbench is the safest bet, no question. The reality is, if you're going to do sophisticated things like speed matching or stuff like that, you're going to be doing some ops mode programming. You're going to have to program on the main side. You just got to learn the criteria of that. Don't try to do things like massive writes, you know, or decoder addressing or any of that other stuff, because you'll readdress every locomotive. But what you need to be able to do is when you're already in a locomotive, you're already looking at these speed tables and momentum configurations that he's looking at, you're going to need to change that on the main in ops mode programming to get a realistic feel of what the effect is you're changing. It's just the reality of layouts. Sorry, Tommy.
So see, I've got that, and it's a much slower crawl than what I had it at before. Again, I've only got a couple feet here, so I really can't let it go to full throttle. But takes a much longer time to get it up to speed. And also, you know, getting back down to speed as well. And the momentum has part of that, but that speed table in conjunction with momentum gives you a lot of, you know, availability to customize the locomotive to, you know, what works best. I mean, that's a nice slow crawl, you know.
And think of the difference as this. The speed table is how fast the locomotive responds to you twisting the knob on your throttle. The momentum is irrelevant of how fast you switch that knob. You can spin it all the way up, but if you have your momentum high, it's still going to take a period of time to get up to speed. So the difference in those two is speed table is how quickly it responds to you, and the momentum is how accurately it recreates the delay in building up speed that's there inherent on the prototype due to weight or train length, etc., etc. They tie together, as Tommy's showing us that at the same time, but they kind of have two different effects in the real world when you are controlling your train with a knob. Those two different things will have a very different feel to you.
So if you guys are watching there, well, you know, the changes from, you know, 4, I got to get my thing here set up again, from 4 to 5, you know, 3 to 4 was very, very subtle. There wasn't, you know, much going on there, as opposed to when I had it a moment ago when I brought it from 4 to 5 or, you know, 4 to 6, it took off a lot faster. So, you know, that's what this is going to do for you guys. Almost done adjusting. Sorry about that. And like I said, you know, you get a couple locomotives next to each other. Now you can start, you know, speed matching the locomotive and, you know, seeing the results of the speed matching. You know, whether you do it on the main or you do it, I'm going to put on the locomotive here on the track, and or you do it with the programmer.
When you get into speed matching, something to bring up is that that Chris done a video on a prior hangout before we started this JMRI business directly. He did a very in-depth description of doing speed matching with the speedometer, over-the-track speedometer. that's really detailed. That's why I haven't thought that speed matching was something that may need to be recovered again, because he really, really went into that in great depth. Now, there's other ways to do it, like counting ties and various other things, but with that speedometer, it's really, his method is great. If there's a video, if you'll go back in the archives on the YouTube channel and look at it, it's pretty exceptional.
Yeah, I like the
Yeah,
idea of using the speed uh, tunnel, or whatever you want to call it.
JMRI has a method integrated into it as well that I had originally thought I would use because I like the idea of its integration as opposed to having to read that display. However, Chris shows, using that speedometer is just so easy for him to interact with for setting those speed tables. But JMRI has a system once you have sensors on your layout, like crossing gate sensors or block occupancy or for signaling, whatever. You got sensors on your layout. You can set a sensor, sensor 1 and sensor 2. You can set the distance or measure the distance and put it into JMRI, and you can tell it that when it hits this sensor and then when it hits this sensor, the time difference between those two, it will calculate that and give you a speed. That's pretty handy, and that's a nice feature to have no matter what. And you can do that. But the little speedometer tunnel is really nice.
Yeah.
Couple ways. There's multiple ways to skin that cat.
it sure is.
We're talking about computers, so yeah, you're going to have multiple ways.
Yeah, if you like skinning cats, that is.
All right, so I had the kind of locomotives on the track there. I don't know if you guys got a chance to see it. They're both running. They're off slightly. This table would need a little more work, but just to get the idea across there. That's one way of doing it. There's a more in-depth, like Andy was saying, in-depth videos out there in speed matching, and perhaps when we get Chris online again with us on the channel, he can kind of go into that in more detail. All right, so if you recall, the next couple things that we had with the locomotive that I wanted to change had to do with the sound. So I go up to the ribbon here.
All right, Tommy.
And we go up to, yeah.
Tommy, if you don't mind, since you're kind of in between fixing to change to another topic there, let me do a real quick announcement here.
Sure, go right ahead.
Just want to say Tuesday Night Hangouts is a proud sponsor of the YouTube Mile Builders, the eMag, and the YouTube Mile Builders live show. The website is youtubemilebuilders.com. You can go there and get all your schedules for the Tuesday Night Hangouts and for the live show, and also see when the eMag's coming out and download the eMag from there, which is PDF files. So if you haven't got all the back issues, you can do that if you like to get caught up on. And you can sign up for notifications when the e-magazine comes out. You'll get an email letting you know it's out, so you can go to youtubemilebuilders.com and be able to download it. All right, Tommy, back to you.
No problem. So like I said a moment ago, let's see if I can turn the volume up on this guy here. And let's get the right locomotive selected. All right. So like I had a moment ago, I've got a locomotive here out of the box. The prime mover is kind of soft sounding. The horn is really loud, or I'm sorry, the bell is really loud. Horn is, mediocre. I put all that together. I've got something I'm not really happy with. So what we're going to do is, I'm going to mute the engine again here real quick. I'm going to go back up to the ribbon here at the top, and there's one here called sound levels. We've got everything here from master volume, air horn volume, bell, diesel exhaust, or the prime mover sound, dynamic brake, and et cetera, et cetera. So this really is a matter of trial and error. Setting it on here, you can program these sound values, on the main, but I'm gonna crank this thing up. Sometimes you get an MTH or a Broadway Limited, and it's really loud, and you may even bring that down a little bit. I'm going to bring the air horn, make sure that's all the way up. I'm going to bring the bell volume, probably, way down. And if I don't like it, I come back in here and I change it again. We'll bring this all the way up for the prime mover, And you know what? That's probably good enough to start. Just like we did before, we're going to write the changes on this sheet. Let me first move the locomotive to the other track here. Bear with me just a moment. All right. Hit the button. You see the changes on the screen, and now it's cleared white. So whatever I just did here is going to reflect on the engine. So let me put that back on the, sorry, it's cutting in and out as I'm putting it in the track here one-handed. All right, so I put it back on the track there. Let's unmute it. A much greater sound in the prime mover. Let's see what that bell sounds like. Wow, you know what? I made the bell a little too quiet, didn't I? Well, I got a better horn. Or a better volume out of the horn. So what I'm going to do is I'm going to take this, I'm going to put it back on program track. Go back to here. I'm going to take the bell volume. I brought it down too low. I'm going to bring that back up a little bit. Like I said, there's some trial and error here.
Tommie, before you write that, check the trucks again. Check
trucks are good.
Harley, okay.
Yeah, they're good.
Okay.
Write changes on the sheet there. I'm going to take this, put it back on the main. Grab my throttle. Just a little bit better. Well, but you guys, I could probably use just a little bit more. What do you think?
Yeah.
A little more volume on that. And what my little setup really needs is a rerailer. That would have been good. So we'll bring that bell volume up, you know, maybe up to somewhere around 50. Now, in this particular decoder, this is, like I said, a soundtracks. It has different horn settings. So I just went up to the sound tab up here in the ribbon. We were at sound levels before, and it has a choice of different horns. So I'm just going to pick a different one. Not sure if that's right or not. Just pick the different horn at random. Hopefully that's not the one that's on there right now. If not, I'll pick a different one yet. I'm going to write that to it. It wrote, it cleared. Put this back on the main. Get my throttle. That was a different horn, isn't it?
Yeah.
What about that bell, guys? Think the bell volume's pretty good?
Yeah.
All right. Put that in the programmer. And that's pretty much what I have. Just to review real quick, what we did is we had a roster entry. We put in some basic information about the locomotive, whatever it is you want. It's all user-entered information. Doesn't change anything on the decoder. You know, pick a numbering or identification system, road number, road name, you know, any of the other good stuff. Basic was, in this case, we used it for decoder address change. Motor, in this case, we were able to program some momentum. There was some basic speed control and a speed table to set a start voltage, you know, where you want that very first bar here to start with, and then this is kind of an odd-long different type of curve here, but you can customize that curve to speed match locomotives or to set different locomotive types. A curve for this switcher here is going to be different than a curve for a typical passenger engine like an F40 is going to be different than an SD40 road engine. You can have different types of curves, or you can have different types of curves for each of those engines to make things more prototypical. Or you can even do the opposite. You can simplify the curves for all the locomotives so they all play nice, with each other. You don't have one, pulling the other one or pushing the other one, and you have things getting uncoupled and stuff like that. So it really depends on how you want to manage your curves amongst, your different locomotives.
Yeah, I know a lot of people prefer to have theirs so that when it puts it on the track and they hit speed step 1, that the engine actually just kind of starts up right there. Lets sound and everything get up to whatever it's supposed to be, and then once they hit speed step 2, it'll start moving then. So this right here will make it real easy to do.
And that's right. Certain decoders will allow that better than others. Some decoders, like the soundtracks I have here, if I were to put all these, down to, 0, oops, it won't even start till I get to, let's just say speed step 7 or 10 or something by doing that.
Yeah.
But I don't think the sound will increase until the motor actually starts to move, in the case of the soundtracks.
Yeah, I mean, they just like it when they select that engine, and then they just go to speed step 1 just to have the sound and everything like the engine starting up.
I suppose if you have it set low enough, you can set speed step 1 to notch up without having the engine move or have it just appear that it's not moving.
Mm-hmm.
What I've done in the past is I've run 2 decoders in an engine like this. I'll have one decoder that will run mobile functions and will react to a speed table in a certain manner, and I'll have a second decoder that'll work with just sound, and I'll program them on different addresses to get the ball rolling, and I'll have that speed table set at a different curve so it'll notch up quicker, notch down quicker, but it'll respond a little bit differently than what the mobile decoder is doing. And at the end of it all, I just program the 2 decoders to have the same address so they work the same. Digitrax has a certain series of decoders that work in tandem one of them is called a sound bug, where you can do some of that with. But you can do other manufacturers as well.
And there's some current kind of philosophies that are growing in popularity, like manual notching and some of that stuff, to let you more control the way the locomotive is responding versus the way it sounds, so that you can make the locomotive creep along at 6 or 8 miles an hour with a heavy load behind it, but sound like it's at notch 8 doing everything it can do. But those are some pretty advanced operational things that I hope to get into at some point in the future that will make the layout feel more prototypical.
That's right. You can do certain things with decoders, but when you're running one decoder, you only can do so much with certain manufacturers, and certain manufacturers do better jobs than others. Not all things are equal. But yeah, manual notching and stuff like that is another way of going about doing it.
Yeah, that's been growing in popularity. A few people have really made that popular, like Mike Confalone, who does a lot of really advanced operational and emphasizes the use of sound in operation, where he's done things like when it's climbing a grade, he'll run that locomotive at 6 or 8 miles an hour, but the locomotive is screaming as if it were at notch 8, and that's done with something called manual notching. And they've done some other things where they make the locomotive still be moving, but basically turn the sound off so that they get the or idle the sound so they get the sound sense of a locomotive that's just coasting along, whereas our locomotives don't coast the way the prototype does. But on a 2% grade with 100,000 tons behind you, that locomotives coast, and we have to fake that.
So to continue with the review, we looked at a couple different sound levels here. I turned the volume all the way up. I turned the air horn all the way up. I turned the prime mover or the exhaust sound of the prime mover all the way up. I turned the bell down substantially to kind of overcome what it sounded like out of the box. And there's other functions, as you can see here, that you can mess with and do different things with. And then I went into the sound part, and I just went through and I changed the horn. And again, there's different horn types. And again, not all manufacturers do this. Soundtrax does this. I believe Loc Sound's doing this. Digitrax does not. That's a whole other thing I can get into about recording and programming your own sounds, and you can do all kinds of customized stuff, but it's a different avenue than JMRI. So that's pretty much what I have for this video. I'm gonna turn it back over to Johnny here and Andy, and we'll
I'd
go
like
from
to
there.
back a couple things up and kind of emphasize a couple things Tommie mentioned, especially early on, a couple points in his presentation when he was talking about or reviewing the hardware, is that you can use the Digitrax command station, and use that interface, computer interface, as pseudo standalone units or whatever in the way that they function. And that's really where the unit that I use came out of that capability. The NMRA set a DCC standard which allows these things to interoperate. Like he also mentioned about decoders. That doesn't mean they interoperate exactly the same. Otherwise there would be no difference in buying a Loc Sound or a Tommie or a NCE versus a Digitrax. They're not all created equal, but the basic functionality, the basic talking amongst these things is standardized and allows multiple manufacturers to work together to a degree and to an extent. And that's where the piece of hardware that I use come from. The Sprog came out as a standalone programmer. So instead of swapping locomotives back and forth, or having actually more relevant than that, having this complicated toggle switch arrangement to toggle the program track to operational ops mode if it's a part of your layout, put it back to your layout, or to switch it into program track mode. The Sprog company or whoever came out with the Sprog device as a programmer. That was the goal of it initially, was you would have your NCE or Digitrax system, and you'd have a Sprog hooked to your program track. And JMRI, in their wisdom, allows multiple interfaces configured together, and allows us to do some complicated architecture of allowing us to control multiple pieces of hardware. I do that now. I use my Sprog, and I also use some other interactions with other hardware, and I have multiple interfaces selected in my interface configuration. In the place where you would go set up your NCE or your Digitrax system, you can have multiple of those pieces of hardware. You can have a Digitrax and an NCE system. And there are people who do that. There's a guy in California modeling the B&O Western Maryland Railroad, and he has both NCE and Digitrax systems. There's advantages to having that type of arrangement for him. So you can have multiple interfaces, and so you may want to consider, it's ever so slightly more expensive, but you can buy an NCE command station, or a power cab or what have you, or you can buy a Digitrax Chief or whatever system you want to buy, and you can buy interface for $30 or something like that, or you could buy a Sprog and use it just as a programmer, just for Decoder Pro, as a standalone unit, and it would be completely compatible either way. The programming that you make on the NCE or on the Sprog would come over to Digitrax. There's a few things that are not necessarily the same, like consisting and stuff, but for things like dealing with a locomotive on a programming track, the Sprog is very handy for doing that. And I initially bought my Sprog just so I could get programming locomotives, with the thought that I was going to go buy a couple $1,000s worth of NCE equipment and wireless throttles, etc., down the road as I got my layout built. And I just really liked the use of the Sprog and the Y throttle on a set of iPods, so I ended up just sticking with it. But you can just use the Sprog just as a programmer, and it's a really good investment to keep you from having to have toggle switches or any of this complicated business set up to do that. You can have a Sprog just dedicated to programming track. That was kind of a relative thing about what he was talking about with compatibility between multiple vendors, is that you can use some of this stuff, and as you get more advanced, you will want to or need to use multiple vendors' products. So even though I use Sprog equipment, I will be using some of the Digitrax technologies that are pseudo-proprietary to Digitrax for, say, my signaling system or something like that, unless LCC advances faster than I think it will. And in that case, I'll be using Sprog and then LCC to control my signal system. So don't think that your buy-in to a single vendor means that everything you buy has to be Digitrax. There's a lot of advantage to it not just being Digitrax. So that's one big item of that. Also, something I wanted to bring up about his adjustment of speed curves is that there is a big advantage to messing with speed curves for the benefit of speed matching locomotives. And like I suggested, go back and look at Chris Heili's video on how to speed match locomotives using the Accutrack speedometer. It's a great video, and he really went in deep about how to and in depth about how to get your locomotives very, very precisely speed matched, even in such a way that you can tell their scale speed by the speed step of your throttle. It's really handy to be able to look down at your throttle and realize your locomotive's doing 28 miles an hour, 25 miles an hour. However, especially what Tommie was showing tonight doesn't necessarily relate just to actually what he did. More specifically, doesn't relate to just consisting and speed matching locomotives. Adjusting those speed curves is going to really affect even the use of single locomotives. And you need to think about this as tailoring the locomotive to how you operate, what you're comfortable with. You know, high momentums may be very, very realistic, but if they drive you crazy and you end up running your locomotive off the end of the layout, then it's not really advantageous to be prototypical. You know, it's not that prototypical to run a locomotive into the Grand Canyon. So, you know, use those with some sensitivity. Also, you need to tailor the speed curves, especially let you tailor your locomotives to your layout. If you have a 2-foot by 8-foot switching layout, your momentum especially, and even to a degree, your speed curves are going to be quite different than somebody who has a basement empire. You know, I can get away with fairly large momentum because I've got enough room to run a locomotive. So you need to tailor it to the way you operate, what you're operating. Like you know, Tommie mentioned that a passenger train with a you know, a PA or some locomotive such as that on the front of 4 or 5 cars is going to act very different in the real world, and hence should act very different with regard to your speed curve on the model than a big articulated locomotive with 160 coal cars behind it. That's a very, very different reaction. And the decoders don't know the difference. The decoder's just going to put power to an electric motor. So the speed curves let us make those electric motors recreate the reality of gravity and weight and mass. And so think about that. What are you modeling? And match your speed curve to that. If it's a passenger train, or if it's a freight locomotive, or if it's a yard switch engine, or if it's a consist of 6 locomotives, those speed curves are going to be very, very different. And again, they're going to be very, very different on a 2-foot by 8-foot switching layout than they would be on a you know, a massive basement empire. So speed curves are pretty handy for that, and not just for speed matching for the purposes of consisting locomotives. Of course, that, you know, that's something we all think about doing there.
Chris brought up a good thing too, is using speed tables, see what the top speed is of that engine.
Yeah.
And set your speed table for that, so no matter how far you crank the knob up, once it hits that maximum speed, it's not going to go over it.
Right.
Keep that realism in there too.
Or even what the speed limit in a given area. If you have, again, a 2-foot by 8-foot industrial switching lane where the top speed was 15 or 20 scale miles an hour or miles an hour, set the top speed of your locomotive to that. There's not a whole lot of advantage of being able to do 60. You're not going to do it anyway. So, and also the smaller your window of speed. So if you have a speed range of 0 to 100 miles an hour on an Amtrak train, every speed notch is going to be a fairly going to be more of an increase. Whereas if you reduce your trains down to, say, where they can only go up to 35 miles an hour, which is what I've got my freight steam locomotive set to do, I think 40 or so scale miles an hour, because that's everything they can do. The sensitivity of speed is it's just much more sensitive.
Now, Andy, if you guys switch over to my screen real quick, and to kind of show that, I've just taken this last one here and I've brought it down some.
Awesome.
And basically what I'm doing is I'm limiting the top end of the locomotive.
Yep.
So you can kind of go ahead and set that wherever.
That's all you've got. Now, and other people have done this in some interesting ways. Again, Mike Confalone, who's done really, really advanced stuff with DCC. He's definitely a guy worth checking out if you're interested in the relationship of DCC, especially with sound, to realistic operation. Is that he put a physical speed stop on his Digitrax UT or his utility throttles. They only go so high. However, you can do that with JMRI. He done it with a physical stop on. It actually has a the knob only turns about a third of the way or so. So when an engineer operating on his layout hits that point, the locomotive's at notch 8. That's everything it'll do. That's it. That's all you got. And that's what you got in the real world. Things that we have to remember is you don't climb into a locomotive of any type for the most part and have a gas pedal or a rheostat or a knob. There's some very, very early switcher locomotives in the late 40s, something that had rheostats on them, but for the most part that does not exist. The diesel locomotives have notches. They do notch 1, notch 2, notch 3, notch 4. If I could do it, I would much prefer my throttles to give me 8 speed steps. Just those are the notches you've got, and you'd have to switch back and forth between them. And that's what they do in the real world. A a guy operating a yard will not just slowly speed up and slowly slow down and slowly speed up, slowly slow down as he's shunting or pushing cars. He'll kick it up to notch 8, jerk it back down to neutral, and let it coast for a second. He'll throw some power to it, let it coast back down. And there's some things you can do in the control of your speed tables to recreate that effect. So another thing is if you're modeling anything close to prototypical, if you're looking at the Santa Fe Railroad or if you're looking at the 1970s, go look at how they operated those engines and try to recreate that with your speed tables if you care about recreating that effect.
Yeah.
Let's see.
Well,
so
I'll tell you what I do. I lost my camera. It won't come back on. So, we're coming
Here's
up.
an example of some notches there. If you click back on mine there.
Right. I like that effect myself too. I'm real fond of operating that way.
And you could go through and you can round those and stuff and do different things with it, but
sure.
I just kind of set that quick, but you can do notches.
Yeah. And then do we want to show the Johnny, do you want to get into the profiler template or the duplication of configuration profiles or the exporting or saving of configuration profiles of locomotives? We don't have any questions yet.
No, we don't have any questions. If you guys want to touch on that for a few minutes, we can.
Well, and
just show that it is there and give them an idea.
And you want to screen share, Andy?
Yeah, did that work for you? Yes. Okay. And this won't take 2 or 3 minutes, but one of the things that I really wanted to do with this JMRI thing that we're doing here, part of demystifying it for people is to stop you from being afraid of it. Not being afraid to get in and mess with your locomotives. Once you've got a locomotive set the way you like it, you've got all of this criteria set exactly the way you want this stuff. There's a few things that you benefit by doing that. Another thing I want to mention is that I go to the trouble of putting all this criteria in, all the little details I put in as I move on to the other things like operations. You'll want that criteria in there. All right, so in your roster, this is so Decoder Pro, you'll get used to dealing with this interface. There's a couple items that I want to just quickly touch on that are pretty handy. One of those is the ability to duplicate. So I've got another Y6B on the way. It's nice to be able to have one of them set up exactly the way you want. That's really common on any decent size layout to have half dozen SD40s. Once you've programmed one, set the speed curves, program the the way the lights work and the functions and all the sound volumes that you want, there's no point in going back and manually setting all that stuff for another one. You can just duplicate that item to the next item. That's pretty handy capability and something that a lot of people don't think about doing, that is program them individually. You can also duplicate for the purpose of recovering, but what I do is, and there used to be a save function that me and Tommie were talking about a few minutes ago, but it seems to have disappeared in version 4, is that you can export these entries. So let's say that you've got your Y6B, or I've got my Y6B functioning basically the way I want it, but there's some things that are just not right, and I want to get into the details of it, but I don't want to go off the deep end. What if I can't get it back as good as I've got it here? You can go and export that roster entry and this will give you the capability to save that to a file, and there's somewhere down through here some XMLs that I've saved. You can export that locomotive's XML file. What that'll mean is that you can export that, and then you can go in here and go make any change you want. And if you don't like that change, just go delete that locomotive out of there and go back and import that roster entry again, and you're right back where you were. So don't be afraid to go make complicated, advanced changes to the system, or to a particular locomotive, or even to the whole system. Something I showed on one of the very early JMRI things, being able to back up your configuration profile. In Preferences, you can go to your configuration profile, and you can export that as a zip. You can see on my desktop is my most recent backup of that file. So what I'll do is, once I have everything somewhat like I want, like I've been working with Panel Pro lately, and I had everything working before I started messing with Panel Pro, so I exported that thing. And nothing I do with Panel Pro will cause me to lose that backup. I can delete that. I can just go back to where I started without any fear of losing all the work I've already done. So my biggest incentive with what I'm showing you here is so that you're not afraid to play. You're not afraid to get in here and mess with stuff and break things, that there's an easy way to get back. So easily with this is just to export your roster entry. It'll save all the configuration about your locomotive, everything that's listed in your program panel, all these details, they'll all be kept, and you can bring those back in if you change them and you don't like what you've got. You can do the same thing with all of JMRI, which is also handy if you move JMRI from one computer to another. So just a couple things I want to touch on. Like I said, the big reason there is to encourage you to not be afraid to play with this stuff.
Mm-hmm. Well, it don't look like we're going to have any questions tonight, so I tried to ask what I could for right now. Yeah, get that to work out. Well, like I said, I lost my camera, so let me try something here and see. Y'all gonna have to tell me if this is working or not.
Yeah, just fine.
Oh, is it?
Yep.
Okay, I guess I don't have to have a camera for that. Tommie, do you have anything else you want to add?
You know, one little thing we talked about early on, and I forgotten about up until a minute ago. Let me turn my camera back on. Is, let's say you got a locomotive, and I know what this is, and I know what it has. But let's say you went to your hobby store, or you went to a train show or some kind of swap meet, and you picked up a locomotive, and it's got DCC in it, but you don't know what the hell it has. And one of the things you can do is go into basic here. Is you can do, let me get focused on it real quick. You can read what the decoder has. And that's what this is right here.
But only on a programming track. This is a feature that is lost when you're doing ops mode programming.
So, and it's going to read back what the locomotive has. It's going to give you what the address is and all that good stuff. Another thing you can do is here on the ribbon, there's a button called CVs. And within this, you can get a really good idea, or not really good, you can get an idea exactly what has been programmed to that locomotive, what the momentums are. If you see earlier, we did 75 and 75 for the momentum, that's CV3 and CV4. With most manufacturers, a decoder reset is setting CV8 to a value of 8. So you could also do that in this application as well. But there's a good way, if you got something you don't know what you have, you can go in, you can see what the CVs are, and you can go in and see what the address is, using these two tabs on the ribbon.
Yeah, that's a good feature. Especially if you're buying a used engine, DCC used engine.
Or if you've taken it to a club layout and made changes, coming back and reading those data back into your JMRI, for example, there's a few reasons why you're going to use that feature. That's a really handy thing.
Yeah, I guess create it as a profile for next time you go back to that layout, you can just reload those settings again, right?
Right. Or, for example, what if you're at a club and or somebody brings a locomotive over to your layout is a better example. Somebody brings over an SD40-2 and their configuration is just impeccable, a lot better than what yours is. You really like the way that runs. Stick it on your programming track, read its values in, and then you can build a profile that you can put all your SD40-2s to that profile. So you can learn from other people and what they've been able to put into their decoders. Now that's not going to work if your decoders are massively different necessarily, but those are things you can use in the real world.
Yeah. Anything else, Tommy?
Oh, I think that's pretty good for one night.
Yeah. Yeah. I don't know why you still presenting. All right, let's see. All right, is that presenting back to everyone? The YouTube Model Builders page?
No, just a black screen. Not for me. All I've got's a black screen.
All right, I got reduced screen share then.
Yep.
You see, I'm still trying to learn all this stuff.
There you go.
I'm not as fast as Dude and Barry are.
Hey, doing just fine.
They're the experts. All right, well, I'll tell you what, I got 1111, so we've had no questions. So I guess everybody's understanding what was said tonight. So I guess we'll just call this one wrapped up then. So with that said, I want to say keep checking back on the YouTubeModelBuilders.com website for all the latest news and info on presentations. Tuesday night presentations are topic oriented. The eMag and the live show schedules. That's YouTubeModelBuilders.com where you get schedules for the live show and the Tuesday night presentations. Thursday night is general talk. It could be any topic that anyone wants to bring up. Live show is once a month, and that's usually the third Saturday. We just had one where we announced the winners for the Big Bill contest. Then the eMag is bi-monthly, comes out every 2 months. Tuesday night presentations is every week, and that has a different presenter each week. That'll be Dude, Troy, Gino, and Barry. Each one usually stays within their specific expertise, and they all have some really good shows. Like Ed Selvin would say, really good. But so you can always go to the website, sign up for the eMag notification when it comes out. That way you can go download it when JD and his crew put that out. I want to say thank you to Andy, Tommie, for coming in tonight and giving us another look at the basics of JMRI. And I want to say thank you to the viewers for viewing. And Tariq, if you're still here with us, yo, man, good to see you. All right, gentlemen, this is another one in the can.